Thank you for joining this lesson. We're going to discuss linear motion. In number 15, we are told that the figure, which is 11, shows the motion of a trolley on a ticker timer tape. It's drawn to scale. Then we are told that the ticker has frequency of 50 hertz. The diagram is as shown. The diagram is showing us that there is motion according to this arrow. Therefore, the tape is being pulled towards the left-hand side. Calculate velocity between A and B. Just before we go to the velocity, it's good we get periodic time. The time interval taken by the ticker to make the dots shown here. So the ticker is taking a time to make a dot, then another one, then another one. So the intervals can be evaluated by taking a frequency, then we obtain its reciprocal according to waves. So 50, then reciprocal is 0.02 seconds. So from one dot to the next, there is a time interval 0.02 seconds. Now with that, we can evaluate the questions. Calculate velocity between A and B. Now that it has been drawn to scale, it means we have to determine distances. So we first of all have to get the distance between A and B. So between A and B, I'm having a distance of, this is 1.4, exactly 1.4 centimeters. 1.4 centimeters. So this is 1.4 centimeters. So that I may do away with the measurements, let me also get the distance between C and D, because we have another region here. Between C and D, we can also determine the distance, and I'm getting exactly 7.7 centimeters. 7.7 centimeters. Now we can continue. 7.7 centimeters. Distance between A and B. Velocity, that is. So velocity between A and B. Velocity is usually speed in a specified direction. So we need distance or displacement out of time. Because the interval is just 1, then we need a distance of 1.4 out of 0.02. So 1.4 out of 0.02, and this gives us exactly 70 centimeters per second. 70 centimeters per second. The same velocity between A and B can also be evaluated as 0.0014 out of 0.02. And this becomes 0.7. This will be now meters. I've just converted the distance. Meters per second. Let's get to part B. We need velocity between C and D. The distance is already 7.7 out of. Remember now, between C and D, the intervals are 2. We have a dot here and another one. So there is the interval and the interval here, and each is taking 0.02 seconds. Therefore, we will divide by 0.02, because the intervals are 2. So the time taken to cover 7.7 will be calculated by, and this becomes 192.5 centimeters per second. That is the velocity, or this can also be stated as the velocity between C and D can be given as, we make this 1 meters, so 1.925, this will be meters per second, 1.925 meters per second. Then now we continue in part 3. We are calculating acceleration of the trolley during the motion. It's good to know that the acceleration of a trolley is usually evaluated by when we take the final velocity minus initial velocity divided by the time taken. In this case, we need the final velocity, which is eventually 1.925 minus the initial velocity, which was 0.7 divided by the time taken. So we have to multiply the intervals with the time within one interval, which is 0.2, so times a certain number of intervals, which I'm going to show you how to come up with them. So the number of intervals between the two regions is evaluated by, we take the number of intervals between A and B and we divide them by 2. So it means between A and B, there is only one interval, so we divide it by 2, we get half. Again, between C and D, we have 2 intervals, we divide them by 2, so we get 1. Therefore, we're going to use 1 interval for CD, but a half intervals for AB. Therefore, we have half and 1. Then the intervals now between B and C will be calculated or counted as they are. So we're going to have 1, 2, 3. Then we take this one, 4, then a half, 4.5. So the intervals are 4.5 total. Within this region, I have the number of intervals, and that is 1. Within this region, I have the intervals, and that is a half, because there is only 1. Then the other intervals between B and C will be counted as they are. 1, 2, 3. 4 and a half. So you have 4 and a half intervals. That is what we should do whenever you are determining acceleration. So I'm going to have 1.925 minus 0.7. Then I divide this by 2 multiplied by, this is a 0.02 multiplied by 4.5. This is going to give me 13.61 meters per second squared. Meters per second squared. When you use velocities in centimeters per second, you will get the answer in centimeters per second squared, though they are not the SI units, but you can still do the same because the distances have been provided in centimeters. Finally, we got a graphical question here. On the grid provided, sketch a graph of displacement against the time of a body in free fall. When a body is in free fall, it should be noted that that body is accelerating towards the earth, and therefore, because it is accelerating, then acceleration in a displacement time graph means that the graph is going to be like this. This is a free fall. You know, if the body had been thrown vertically upwards, it could have decelerated, and such a body would have traced a distance time graph like this. This is a vertical projection. Vertical projection, or when a body is vertically projected, that is how it will have behaved. So this is increasing velocity. This is increasing velocity, or we can call it uniform acceleration. So the body is accelerating towards the ground. That is how the graph should appear. Thank you for following. Subscribe and share.